I would now like to invite Air Commodore A G Kshirsagar from the Indian Air Force to make his presentation.
Dr. Satish Kumar, CCR&D, and all the esteemed members from the academia. It's it's encouraging, at the same time very. I feel very awed to be in the presence of such eminent personalities who are in this gathering, encouraging in a way that their presence, your presence over here would definitely go a long way in solving some of the issues that we as the users in the Indian Air Force face, and as a continuous process look for solutions. So I would start with a small quote by Dr. APJ Abdul Kalam, and it's a very well-known quote, I suppose, from the Vision 2020 book of his. And this is what the driving factor for all of us, both from the at all three levels, from the defense to the DRDO as well as to the academicians. As you all know, Indian Air Force operates cutting-edge technology defense equipment, most of which is imported as of now. Our dependence on imported equipment is close to about 70%, and this dependence continues throughout the life cycle of the equipment as of now. We do depend upon critical technologies, critical equipment, critical spares. All of these have to either get repaired, overhauled, imported all the time. We have had limited success in indigenous production. As you all know, we are having a continuous interface with the industries from our base repair depots, and so far what we have achieved is the low cost, high volume items like split pins and other small items that you can think of. These are already been indigenized, and we have moved towards having major aggregates indigenization. However, we still lack in critical technologies and critical components, which we still need to go back to OEM for their repairs, maintenance, or procurement. And therefore, this gives there is definitely a need to encourage R&D in the educational institute and industry to give us those kind of independent technologies. As we see, there are two distinct avenues for research and development. One is in a completely new technologies, which the SA2RM had spoken about in the first session. These are the ones which are absolutely ab initio, new technologies on which the world is working on, and we also need to graduate into that. By and large, these have been already spelled out in the technology perspective and capability roadmap, which is the information available in the public domain, and SA2RM has elaborated in quite a bit of details as to what the DRDO is working on these areas. But there is a separately different kind of an area which we would like to, I would like to touch upon some of these areas, and that is to support the operations of the aircraft and other weapon systems already inducted into Indian Air Force. We have this equipment with us, but we do not have critical technologies to support this equipment. So there is an area, or there is an avenue for carrying out research and development into these areas, which will support us in our operations and maintenance of this equipment. I would not spend, though I had planned to spend few moments on this, but these are the technologies for which enough has been said by SA2RM, and I would not dare to expand on any of these issues anymore. So directly going on to the avenues for R&D for the educational institutes. When I was looking at and was told to prepare for this presentation, and when we looked at some of the technologies that we are presently looking at, it was a very vast canvas that was that came up in front of me. And given the time frame of what we are told to present, I am only touching upon some of the critical technologies that we are looking for solutions, and this is by no way a comprehensive kind of a roadmap, but just an indicator. Okay, we prioritize these technologies based on primarily as the MOD's directions on reduction of import dependence. We are also wanting these technologies because of prohibitive cost of import of these technologies. Indigenous capability development as an independent driver is a requirement. There are some technology which are causing production holdups, or they cause our aircraft to remain on ground, and therefore we need help from the academia on that ground. And of course, there are many areas where we continue to, as was brought out by my previous speaker from the Army, that the OEMs are no longer supporting us into those equipment, and we find difficulties in maintaining them. So one of the first of the areas which I would like to touch upon is protective coatings on aero engine blades. You see, compressor and the rotor blades of the aero engines do tend to wear out while operating in harsh conditions that we have, as far as the humidity, the temperatures, the salt, as well as the dust environment, and they do erode over a period of time. Whenever we operate them for a longer duration and they come up for overhauls, they get rejected, or there is a degradation in the performance. What we have as a technology which is available with the foreign vendors is that there is a protective coating which is placed on the blades which prevent such erosion. So I've just said that we are looking at something like physical vapor deposition is one such technique, and there could be many other techniques which would prevent aero engine blades from deteriorating in their performance. Every manufacturer assigns a very limited life to aircraft and engines at the initial stages because of their very conservative estimates of utilization. But while during the when we continue to use them over a period of time, and because of various reasons, we do have to improve upon or extend life of this equipment. And there are techniques which allow us to check the integrity of the components and the aircraft airframes and other components, which are called as non-destructive evaluation techniques. And we do carry out in Air Force, we do carry out very regularly the life extension studies for detecting extending the life of the equipment. And newer techniques in these areas, the technology in this area, if we could bring to the table, would allow us to carry out a better assessment of the life extension of this equipment. Another area where we would like help from the academic institutions is development of glues. A very huge types of glues are being used on for abradable coatings to provide air labyrinth on aero engines. These have to be capable of withstanding very high temperatures and sustain them over a long period of time. They have to have high shear strength and have to be non-coagulating. These are some of the, just some of the properties which I am listing out over here as a thought process to provoke the thought process among the scientists and institutions, where we could look at such development of glues, where they would help us in increasing the life of the component or rejuvenating it in the process. Another technology which we would look for is the rubber compounds. Rubber compounds are used in the aviation industry in a very big way. We use them as seals, gasket, hoses, and whole lot of things as we what we use them here. They need a huge number of properties to sustain them in the aviation industry. These are based on their applications. These are the various properties that they need to have, and we need to develop rubber compounds to suit the specific need based on these characteristics. So if we are in a position to take up the development of rubber compounds as a technology, it would help us in maintaining the equipment, it increasing its life, and reduce our import dependence. Nano composite coating is another area where our aircraft canopies, when they suffer the damage in the form of cuts and marks, they need to be rejuvenated. The nano composite coatings which have been tried out are, one of the examples is that sol gel coating, which we are presently trying it out with ARCI Hyderabad, and there are many more such techniques where we can sort of rejuvenate the aircraft canopies, because this is a very, very high technology item where any rejection, we are still import dependent, and it is something which keeps recurring at a very regular interval in the Indian Air Force. This brings me to the basic factors of cockpit glasses and canopies. These are presently imported. there are various types of construction of canopies which are earlier used to be monolithic, but nowadays with the advancement of the technology, the laminate structures have been used, and transparency, frangibility, weight are some of the considerations which do not permit us. We do not have the technology to manufacture cockpit glass and canopies in India. We do need this technology to improve upon once again our own dependence on the OEM, and as well as have it as an self I would call it a capability to attain for future. Our BRDs carry out large number of reclamation processes. If a component cannot be reclaimed, then it has to be replaced. So if the rejected parts can be reused through reclamation process, now there are plenty of reclamation processes possible. They are like nitriding or metal depositions or many such examples which we are presently using, but I'm sure with your knowledge base, with your experience, you would be able to come up with many more such reclamation processes. And if these are given a boost, these can be thought about and can be explained across to us, we would be more than willing to take them on board for carrying out our reclamation processes. This was primarily intended for actually the some of the private industries which I thought would be participating in this conference. But all the same, these are some of the manufacturing or the processes in which we are expecting some kind of a research work and sort of improvement into the materials, the aviation bearings. Entire aviation bearings are not only in the aero engines but into many other moving components of the aircraft, and it's a very specialist kind of a technology. We do not have this with us. Precision machining, welding, a whole lot of aircraft tires. We had a major breakthrough recently in past with aircraft tires, and we have been able to indigenize the aircraft tires of Su-30 and other aircraft, and there is a big boost being given into that. But this is another area where more research work is possible. Aircraft batteries, we're graduating from lead acid to the silver zinc to NiCad to lithium ion, and whole lot of, there is a whole process which is going on of aircraft battery development. So cockpit displays, which already been talked about, and of course the simulators. My senior army colleague had already spoken about simulators. We in the Indian Air Force also look forward to have full base, fixed base full mission simulators and such kind of simulators in various aspects of training, which could be developed by either the industry or the academicians to help us in training our operators into these areas. How do we do this? We have something called as IAF Technology Board, which is in functioning for last about 3 years. It is under the chairmanship of Air Officer in Charge Maintenance at Air Headquarters for enhancing the capability of and undertaking such R&D work. It was thought of as a medium for exchange of technology related information, and we hope to create a data bank. We encourage the R&D type of projects through IAF Technology Board, which meets at once in 6 months for every year, and year on year we take on projects which are funded by the Indian Air Force through R&D budget, and whenever we find that our budgets are not sufficient, we approach our big brother DRDO or others, and they have been very kind enough to have sponsored any one of our requests and accommodated them very well, and they do also provide the funds for undertaking such research projects. So this is one of the avenues, one of the places where the academic institutions can come forward into these areas which I have just mentioned. This list is by no means comprehensive. This is by no means limiting. It is as we probably interact more and more, the avenues for cooperation between the Indian Air Force and the academicians will improve, and more areas are possible for us to work on. I would just leave this address with you for the purpose of contacting us, and hope to get responses from the interested academic institutions on this issue. I am not in a position to give any specific projects at this stage, But as and when we interact, the requirements would emerge, and that's the way forward. That by more and more interactions, I would like to move forward on this issue. I take this opportunity to thank the Engineering Watch to have provided us a platform of direct interaction with the academicians, as well as act as a hand-holding process, and hope to get more response in this area. Thank you very much, and Jai Hind.